Hey, welcome back, fellow scientists. All right, so hopefully you already watched the video on fermentation by Mr. Anderson, Bozeman Biology. He is a great resource, by the way, if you're missing class or you don't understand something in class or you want it from another perspective or another view. He is spot on. Right, so Khan Academy, Bozeman Biology, Amoeba Sisters, all of those are excellent resources for you. So hopefully this page in your notes, which my page is blank, hopefully your page is filled out a little bit and you gained knowledge from Mr. Anderson. You can ask me questions in class on Thursday if you would like. But I wanna take hopefully just like a very, very small amount of time, maybe 5 minutes, maybe as much as 10 minutes, but very, very small amount of time. Just to introduce another concept or another idea to you called redox reactions, okay? So we already saw, let me get back up here real quick. We already saw, where is it? There it is. We already saw one type of coupled reaction, right? Where something is broken down and then something else is built up. So at ATP, that's broken down into ADP plus inorganic phosphate. So that compound right there loses energy. Right, and then that energy, some of that energy is captured by taking glutamate plus amine group and then combining those two together and then making it into glutamine, which is one of our amino acids. Right, and so that takes energy. That requires energy, which was supplied by this ATP being broken down. So something's broken down, something else is built up. That's one type of coupled reaction, and we see those all throughout our little diagram here that we have already looked at, right? And then just as a reminder, right, we have so many little dots and so many little lines because we want to release just very small packages of energy. We don't want to release energy all in one big thing, right? So next place that we want to go to, just go to the next slide. There it is on your in your packet, right? And I want to talk about redox reactions, which is another type of coupled reaction. So go ahead and write that down. Redox reactions, another type of coupled reactions. I tried to find a good YouTube video so we didn't have to be me talking, but all of them were more focused on chemistry and they went way more in depth than we need to know. So I'm going to try to make this short and sweet and simple. So redox, break it down. Red stands for reduction. Red is reduction. And this is going to sound counterintuitive, but just stick with me. Reduction means gaining electrons. Gaining electrons, right? And the reason why it's called reduction is because before people knew about electrons or different things like that, they would look at the charges and oh, well, it's becoming more negative, so it's being reduced, right? Because electrons have a negative charge. So reduction is gaining electrons. Now, we can't always see electrons, and electrons are shared in bonds, and so it's kind of hard to look at that. But usually electrons follow hydrogen ions, okay? So electrons, we're gaining electrons, or we could follow the hydrogen ions. We're gaining hydrogen ions. And basically here, we're building this up. Building up. Okay, so that's the first part of our redox reaction. Ox is the second part, right? And that stands for oxidation. Oops, OXI. Oxidation. Some of you may have heard rust referred to as oxidation. That's the kind of the technical term for it, which is all good and correct. Oxidation is rust, right? So reduction is gaining electrons. Oxidation is losing electrons. Losing electrons, or we could also say it's losing hydrogens, right? Losing hydrogen ions. And you can tell because oxidation is rust. We're not building up, but we're breaking down. Right, so this is still building up and breaking down. It's still kind of that coupled reaction. But this one, we're looking very specifically at the electrons or at the hydrogen ions, which is why it's classified as a redox reaction. So let's go ahead and let's look at this diagram right here. So we have our already reduced compound. Oh, sorry, I should give you the memory aid. That's right. Our memory aid is oil rig. O-I-L-R-I-G, oil rig. So oxidation is loss. Okay, reduction is gain. Oil rig. Okay, so use that, memorize, use that device to memorize redox reactions. Okay, so we have compound A right here that's already been reduced. It's already gained these electrons. Okay, and so this is going to be the reducing agent in this come on, in this chemical equation. Okay, in this chemical reaction, that's the word I was looking for. In this chemical reaction, it's going to be the reducing agent, and it is going to become oxidized. Okay, it is going to lose electrons. It already gained electrons. It was already reduced, right, in some other chemical reaction in a land far, far away, right? It already had that, so it's the reducing agent. It's going to allow something else to be reduced. It itself is going to be oxidized, okay? And then if we look at compound B right here, okay, this is already oxidized. It's already been oxidized. It's already lost its electrons, okay? Again, in a land far, far away before time began, right? It's already been oxidized. Not really, but before time began, but already been oxidized. So it's the oxidized compound. It's the oxidizing agent. It's going to allow A to be oxidized. It's going to accept the electrons, and compound B, it itself is going to be reduced. Okay? So now where do we see this with cellular respiration? Well, we can go back to here and we can look at our life equation, right? And so C6H12O6, our sugar, okay, that's going to be broken down. That's going to lose its hydrogens. Okay, it's going to lose its electrons. So this is going to be oxidized. So this is going to be oxidized, right? Our oxygen, right, that's going to gain electrons, so that's going to gain hydrogen, that's going to become H2O, right? We can see H2O is oxygen with the addition of some hydrogens. So this is going to be reduced. So this is going to be reduced, right? So this was already, sorry, I'm mixing up my A's and my B's. Right, so the reduced compound is going to be oxidized. So A. So glucose, right, is like A. It's going to be oxidized. It's already been reduced. It's the reducing agent, right? So this is the reducing agent. It's already been reduced. It's going to be oxidized. It's going to be broken down. Okay, this has already been oxidized. This has already lost its electrons. So this is the oxidizing agent. Right, and it's going to be reduced. We're going to add electrons. We're going to add hydrogen ions to it. And then this right here, so water, right, this is our reduced compound. This is after oxygen has been reduced, right? So now this is our reduced compound. Reduced compound. And then CO2, you can see C6H12O6, right? If we take out the hydrogens, and then if we add a couple more oxygens, which we'll get to later on, right? Stoichiometry. Ugh, horrible. That, you can see how we just take away the hydrogens, and then we have C's and O's. So that is our reduced, or sorry, that's our oxidized compound. See, I'm getting it mixed up. Right, it's oxidized, it was broken down, the hydrogens, the electrons were removed. So our CO2 is our oxidized compound, and then because of all of this switching around that's going on, we're able to make ATP or energy. Okay, so that's one example. Another example that we see in cellular respiration and photosynthesis, you remember our baskets, right? So you remember our NAD+. Okay, so this is the structural formula for NAD+. Now you remember what we said our baskets hold, right? Our baskets hold electrons, okay? So empty baskets, they're going to gain electrons. Okay, so they are going to be reduced. They're gaining electrons, so here we have reduction. So this little part up here, this benzene ring right up here, this is going to accept the electrons and the hydrogens, by the way, because we said hydrogens follow electrons, right? And that's going to be reduced to form our full basket. Okay, everything down here stays the same, right? We're just adding 2 electrons up here, right? So one of the electrons goes here and it takes away this formal positive charge. Right, and then the other electron is used to make this bond along with taking one of these electrons from these floating double bonds right here, which you don't need to memorize. You just need to know that this NAD+, right, is being reduced to form NADH, okay? And then our full basket, right? That's going to go over to the electron transport chain, and the electron transport chain, pump number 1, is going to oxidize, right? Is going to oxidize, sorry, I did a reverse underline, is going to oxidize our full basket NADH, and then NADH is going to lose its electrons. So it's going to be oxidized. The pump is going to be reduced, right? And then our used to be full basket NADH is going to be oxidized. It's going to be broken down into our empty basket NAD plus, and then that's going to go back and it's going to be reduced again so that it can take on electrons. So we see even in cellular respiration, right? We see a big picture, right? And then we see even in the small little steps, we see these redox reactions, these oxidation reduction reactions. Okay, so I'm sorry, I'm over time. It's like 10 minutes and 50 seconds. So this has been Mr. Leo. Hopefully this has been informative. You watched another video about fermentation. Take notes on that if you haven't done so already. And then you watched this video on redox reactions. Make sure you have that written down. If you have any questions, we can go over it in class. Thanks for watching, and I will see you on the flip side.